Hello again. Today we have to say another one. A new topic is called the structure of agents. When we are talking about that is the agent, so that is very important component in the artificial intelligence. So we may say that is the foundation of the artificial intelligence too. So the agents is having the combination of two basic components. Number one is called that is the program, and another one is called that is the architecture. If I am saying that is that agent program, it implements the agent function and mapping percepts to the actions. The agent function should map to the percepts and to the actions. The word may be new to you if I am saying that is the percept. In neural networks, we are having that one term is called that is the perceptron. The perceptron is doing that actual simulation of how the neurons is doing its work in that subbrain. It's passing that information and holding that information, and then it has to produce that is the action what that neurons is learned. So when we have to see that is that new thing. The same way here the agent function should map with the current percepts and put it into the action. And another one term is called that is that architecture. In that architecture, already we know every agent program should be run on any one computing devices. So it needs certain sensors and it needs the certain actuators. All should be included into that architecture. So if I am saying that is that architecture is not only that computing power alone, that with that computing power we need physical sensors as well as that actuators. And finally, now we have to come to that definition of the agent. The agent is having architecture plus program. So agent equal to architecture plus program. So architecture means it needs computing plus physical sensors and plus actuators. If we are talking about that is that program, the program it's having agent function that should mapping the percepts, that percepts should be taken into the action. So these are all the basic components that is presented in that agent program. On the next, the agent program should take the current percept as an input from the sensors and return an action to the actuators. Every agent program should know what is its present state. So later we are going to see about the types of that structure agents, but each and every type we have to be understand. So what is the current state, the current percept, so the initial value that should be determined by the agent program. The agent program so takes the current percept as the input because nothing more is available from that environment. In case if I am starting that is the one new function, or I am starting that is one new game, or simple an example. So every home which is having that automatic washing machine, with that automatic washing machine, it has to be understand. So what is the current percept? The machine is running according to that program. At untoward incident, the power is gone off and the power is coming back. The machine shouldn't run from its initial state. So what is that current percept? The machine has to keep in its backup. So in which part the machine that has stopped its process, that process should be continue when the power is restored. So this is the very important concept behind the agent program, and to keep that current percept as the input. So this one keep that available from that environment. And last, the point of that agent program, the agent's action depend on the entire percept sequence. The agent will have to remember the percepts. This is very important. So what I said in that earlier example in the washing machine, the percept should keep what is the state it's past, and what is the state it's current, and what is the state is next it's going to do. It should keep up that is the appropriate sequence. So this is the basic concept in the structure of that agents. And we have to say the four types of the agents in artificial intelligence. Instead of we have to say that's the type, that is the kinds, that has to be grouped. And the first one is called the simple reflex agent, and number two is called the model based reflex agent, and number three goal based agents, and number four is utility based agents. So first we have to see simple reflex agent. The simplest kind of the agents, it selects an actions from the current percept and do that activity or do that enabling of the actuators according to the current percept. The simple reflex agent never considering about the rest of that percept history. So what happened in that earlier, that is not only a big matter. So instead the simple reflex agent should keep the current percept and what's it's actually going on. So in case the simple reflex agent in one example, the two state the vacuum environment, it's having that location and then the status. So this is the two state of the vacuum environment. So already we saw this kind of that vacuum agents in many places. So its activities has to locate the dirt and then it has to return the status of the dirt that has been picked up or not, that area is cleaned or not. So we are defining that is one function which is having that name, the reflex vacuum agent, and it's having the two parameters is called the location and status. So now we are applying that is the condition if status equal to dirty and then return the suck. That means it has to activate the actuators to suck that the particular dirt placed in that specified location or where the percept is identified. If that condition is satisfied and it has to be tracked it out and it has to be settled into that appropriate location, the machine shouldn't be make it ideal in the center of that hole. Just imagine after the completion of that work, the agent is positioned into the hole. It seems to be the disturbance to the walkers, those who are in that wall. So it has to be returned into that certain position. So how we are keeping our brooms in our hole? So we are always putting the broom into the one corner of our hole. The same way this cleaning agent should be kept into the some corner or into that some place. So it has to be desired its present location after the sucking of the dirt, and if it is the location is A and then we are returning, it has to be turned into the right. If its current position is B and it has to be returned into the left. So such example it's depicting so how the simple reflex agent is working. So it's having the only the two varieties of that percepts, that is the location and also status. This is the very good example. Now we have to say how the simplex reflex agent is it's having its schematic diagram. So we know that is that environment, the environment that has to be read. So that is that entity. It's read by its sensor, and we are having that one beautiful term, what the world is like now. So how the world is now. So it has to be given that is the appropriate action. So what action should I do now? So it can't able to decide its own, but instead the what action should I do now should be get it from condition action rules. So what are all the conditions I derived? So what are all that activities the particular agent is due, that has to be defined in the condition action rules. That condition action rules is giving that instruction what action should do by that agent. So that action that has been transferred to the actuators, that actuators is working according to that instructions getting from the conditions defined the rules, and that environment that has been taken over by the particular agent. And the next kind of that model, next kind of that agent is called model based reflex agent. In the model based reflex agent, in the previous the simplex based simple reflex agents, there we talked about that is only the two setup of the status percepts alone. But here we have to be take that is that variety, since we are defining that is that one model and it has to be satisfy the particular task. So this model based reflex agents that has been worked, so it has been worked under the partial observability. So the system that has to be observed certain partial kinds of that environment, and it has to be understand these things, and it has to be devised what are all the states it has to be run, and that has to be sequenced, and appropriate actions should be defined. in this diagram itself we can able to say it's observed that environment through by that sensor, and the sensor has to be devised. So now what should I have to do? The world is like now. So before making that next stage, it has to be analyzed what is the present state. In model based reflex agents, it should keep it up its previous state and its present state, and what should be its next state if it is needed. So that has to be taken over into the consideration. So it has to be understand what is its state. And next one, so how the world is evolves. This question is stating about how the earth is rotating. That means how should I do my job? So what's my job? So what should I do? So how I do? So when should I do? So all these questions that has to be asked in that second part of this decision. And then afterwards, what actions I have to do? So I am returning that is the answer according to that previous one. So always when we have to be defining the state, on the next step we have to be asked these questions. So how, when, what? So these questions we have to be asked. So according to the answers of this question, and we have to be defined, so what should action I do? So all these inputs should be get into that the activity. And next one, we have to be defined the instructions to the actuators. So now that actuators making an instruction, we have to be give. So what are all the conditions and then action rules? In previous, we only define about that is action rules alone in that previous things, conditions and then action rules. In the same way, so here it is also we have to be defined the condition and then action rules. So it's giving that is the input. So what are all that actions it should do by that actuators. So that has been feeded and that has to be get into that environment. On the next two models we have to say, and then it's called that is the goal based agents. In the goal based agents, it has to be defined that is the goal. So what is the target and what is that outcome? So in the goal based we have to be say, so what is the best? So the particular system may have that more than one solution. In that more than one solution, which solution it's giving that more accuracy in that goal? So that has to be defined in the goal based agents. And the next kind of that agent is called that is the utility based agents. In the utility based agents is also it's talking about it's having that more numbers of that opportunity of that actions, and it has to be stay in that particular state. But the state it seems to be that very good or not, that has to be defined. So that only defined by the utility. So in there you have to be asked to be that additional two parameters, so which is called what it will be like if I do action A. So how happy I will be in such a state. So it has to be devised to be that multiples of that actions, and it has to be classified. So which action is giving that good returns and which actions is giving that 100% of that utility. So these things that has to be defined in the utility based agents. So according to that utility and then according to that marks and according to that ranks, the utility based agents has to produce the decision values to the actuators. According to that, this actuators has to be worked. And the last variety is called that is the learning agent. The very good example for the learning agent is called the Sophia. It's having that the citizen in this world under that UAE. So presently the Sophia is also learning that more and more components in day by day. So now its IQ and its intelligence that has been improved. So here it's having the sensors, and then we are making the performance standard according to the critics, and then so feedback, and we are having that is the learning elements, and then so changes, and then so knowledge we have to be trained, and finally we have to be reach it out the goals that has been achieved. So if I am asking that is that any problem with that particular agent, it has to be produced that is the appropriate good outcome, so through by its learning goals. So that has been given into the actuators. So presently if you are asking these questions with that any kind of that humanoids, so according to the purpose of that humanoid, it can able to return that these answers. So these are all the 4 components of this learning agents. So quickly we have to say about the types of that these agents. The number 1, simple reflex agent, number 2, model based reflex agents, and number 3, goal based agents, and finally utility based agents. So thank you.